One two one two.
One two one two.
Good evening, this is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre South. Broadcasting on prime frequency 3541 kHz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3RTV digital channel 1 in full HT, and streaming on my YouTube channel, which you can find within the YouTube search engine. Just type VK3CSJ and look for the live symbol, and of course you'll have to put up with the delay from what you're hearing on 80. It's about 20-second delay on YouTube. But since the broadcast that I do here every Friday is got lots of pictures and graphics and the odd video, I always suggest that you run the TV side of it so you can catch up with all the visuals. And while I'm doing this, just turn down a few things here on the show. All right. Good evening, everyone. This 27th of October, nearly the end of the month, and weather's slowly improving. Anyway, that's it. We'll see you all next week. Anyway, yes, email. We have email address. You can send reports and notices and whatever to vk3ekh@gmail.com, vk3ekh@gmail.com. And we also have a Discord thing running. So if you Google search Discord and look for the radio astronomy, no, it's not radio astronomy, the astronomy chat room, that's all I know it as. For Friday night you'll be able to find the chat room as such, and I can see that Martin VK7JAH is there, and Richard is somewhere there too, I think, VK3VRS, local station, and our resident Mount Burnett astronomer, VK3 KDM David. So thanks for joining in, lads, and I'll just have a quick look at the email address. Email as I speak. G'day Wayne, and he's reporting a fine signal. YouTube and DVT sound and audio spot on. Excellent. Thanks for that. And alright, so far it's the emails there. I'd like to send a special greeting tonight to David, Dave, VK5ZED. If you're listening there, Dave, if you've got access to a computer, have a watch on YouTube, VK3CSJ on YouTube, and what was it? What else was I going to say just then? Anyway, can't remember. But welcome tonight, Dave. Special call out to VK5 Zulu Echo Delta. I hope you're getting a good signal from us on the radio. But like I say, you can see us on the YouTube stream, which is streaming at the moment. Okay, the usual quick rundown of their society for those that are tuning in for the first time. The Astronomical Society of Victoria was founded in 1922, and we're coming up to celebrating its 100 years, and comprises well over 1,600 members scattered about the state of Victoria and Australia and overseas. Membership of the Society is open to anyone with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science and to provide greater facilities for the study among its members, which it is constructively doing up at the Dark Sky site, more ways than one. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start on the noggin at 8 o'clock at the Mollier Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets, and admission is free. And of course, visitors are most welcome indeed. Door is open. Meetings usually go till 10 o'clock, with the aim to finish at 10, finishing with a cup of coffee or a cup of tea and some bickies and general chat. The monthly meetings are usually also, or now are, I should say, being televised on the ASV's YouTube channel, and also on the Facebook page that ASV has. So if you can't get into Melbourne to sit in there at a meeting, by all means you can catch up on the live stream provided. Privileges of membership include the right to borrow books, periodicals and other publications from the extensive library that's also located at the Melbourne Observatory. I always like to say that as soon as you walk in through the door of the library, you get bowled over by the smell of decaying books. In a nice way, of course. There's always I love burying my nose into a book first before I start reading it. The smell of a book, especially if it's a new book. But anyway, there is a library smell, and it's only it's very nice. But apart from all that, the extensive library. You also get, as a member, receipt of the magazine, the ASV's magazine, which is called Crux, which contains a whole lot of articles, and there are sections that generally deal with aspects of astronomy, which are regular. You also get a yearbook. The ASV publishes an annual yearbook, kind of like an almanac of sorts. Access is available to telescopes on members' nights, held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and there's also a photoheliograph. And these are accessible to members too through various meetings that go on. The Society also has a number of 200mm reflectors available for a short period loan. It's the telephone, the telescope loan scheme that ASV has. So you can take a telescope home for a few months and give it a go. Members are also encouraged to make use of the Society's country property located just north of Heathcote, about 90-minute drive north of Melbourne. There are a range of instruments available there, and the larger two, a 300mm and a 1000mm aperture telescope, are accessible through appropriate training if you wish to use them. There's a radio telescope also on the site too, something that I had a lot to do with, getting involved with the radio astronomy section at the time. The 8.5 metre Kennedy dish, and I know there's a few little issues going on at the moment which the guys are working on with the dish, but I know that the Parkes radio, the lads up at the Parkes Radio Telescope are interested in our dish, so we can only hope that things start to move along in the next year, in the new year. Yes, so the 8.5 metre fully steerable radio telescope is accessible to members too, with involvement with the radio astronomy section. Members are encouraged to make and use telescopes, and advice and help on both matters are provided willingly to newcomers desiring to do the same thing. And instrument making is only one of the number of common interest activities catered for within the society. There are 21 sections that make up those activity groups, ranging from deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook, but if you don't have the yearbook, because you can only get the yearbook if you are a member, further information may be obtained by visiting the ASV's website at www.asv.org.au, and notifications of events are given in the Crux Extra, which is an email edition that's published every other week or so to keep members abreast of what might be coming up. So that's an email thing. And ASV will conform to any government health directive if necessary. ASV events may be required to be cancelled, moved and postponed. If you wish to send a mail post, the address is the Secretary, the Astronomical Society of Victoria, GPO Box 1059, GPO Box 1059, Melbourne, Victoria 3001. So that's the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Scattered on that one. Anyway, so that's an introduction to the ASV, and of which I've been a member since 1993. And of course I'm now getting more involved with the astronomy, the optical side of it. The dome hasn't quite been installed yet, but it's getting there. But the 3 metre dome is a happening thing. So as soon as that is up and running, I'll have a telescope in there and start joining the other lads that love looking at the sky through magnifying lenses. And of course the thing that I want to do is stick a camera on it and take some pictures. Hopefully that'll be successful here in a very light polluted Narre Warren South. You're tuned to ASV Radio, VK3 EKH, the official station of the Astronomical Society of Victoria. G'day to Kim, VK5 FUSE. G'day Kim, he's joined the list on the Discord channel, as well as Steve, VK3 SPX. G'day guys, thanks for joining in. And I'll just quickly check my email, the inbox. Steve has sent a report, 20 over 9. And we've also got Brett listening today, VK2CBD. Welcome to the session tonight, Brett. And oh yes, you're watching on the TV. Okay, excellent stuff. All right, I think I'm presentable tonight. I've got a book review, which I don't know whether I'll leave to the end of the night or now, but I might do it now for the hell of it, just to start it off. For those watching the TV, that's the book. Joe Pawsey and the Founding of Australian Radio Astronomy. Early discoveries from the Sun to the Cosmos. Now this was being talked about on the WIA broadcast about 2 broadcasts ago. And I did mention it. This is my second time mentioning it because I bought the book, and it came all the way from Europe via Amazon.com. And my good, it's a heavy book. It's this thick, and it really has a lot of weight to it. Yes, it's a Springer publication, open press, and it is, let me tell you how many pages it is. I think it's 280 something. Lots of blank pages at the back there. Lots of blank pages. Oh, well, there you go, 200 I was going to say. No, in fact, it's 815 pages long. 815 pages long. And the back cover says that this open access book is a biography of Joseph L. Pawsey. It examines not only his life but the birth and growth of the field of radio astronomy and the state of science itself in the 12th century Australia. The book explains how an isolated continent with limited resources grew to be one of the leaders of the study of radio astronomy and the design of instruments to do so. Pawsey made a name for himself in the international astronomy community within a decade after World War II and coined the term radio astronomy. His most valuable talent was his ability to recruit and support bright young scientists who became the technical and methodological innovators of the era, building new telescopes from the Mills Cross and Chris Christensen Cross to the Parkes Radio Telescope. The development of aperture synthesis and the controversy surrounding the cosmological interpretation of the first major survey, which resulted in the Sydney Research Group's disagreements with Nobel laureate Martin Ryle, play major roles in this story. This book also shows the connections among prominent astronomers like Oort, Minowski, Bade, Sturvey, and famous scientists in the UK such as J.A. Ratcliffe, Edward Appleton, and Henry Tiswood, and the engineers and physicists in Australia who helped develop the field of radio astronomy. Pawsey was appointed the second director of the National Radio Astronomy Observatory, Greenbank, West Virginia, in October 1961, and he died in Sydney at the age of 54 in late November 1962. Upper-level students, scientists and historians will find the information, much of it from primary sources, relevant to any study of Joseph Pawsey or radio astronomy. 815 pages, and it weighs a ton, and it's beautiful quality. It's semi-gloss. Every page is kind of semi-gloss to it. The images are beautiful and smattered with a little bit of colour throughout. And if you do this, if you open up the book like this, for those watching the TV, if you open up the book like this and put your face into it, oh, that is bliss. The smell of a new book. You just got to love it. Anyway, there it is. I actually had some graphics on the screen, but I'm holding the book up. That's good enough. And it weighs a ton. It's a beautiful book, and I hope that when I retire in 4 or 5 years' time, I'll be able to sit down and read it. So where can I put it? I'll just put it on the floor here. Oh, because I've got so much clutter on this bench here. 20 past the hour already. Oh, good evening, everyone. I trust everybody is well. Okay. You're tuned to ASV Radio VK3 Echo Kilo Hotel. There is a devil comet, and it's headed our way, but that's okay. Sure, it's big and looks weird, but Comet Pons Brooks is no danger. and actually has sky watchers very excited. Published October 25, 2023, courtesy of astronomy.com. Comets have gotten, I never like that word when they just pick that, gotten or got. It's one of those words I'm not really fond of, but I can pronounce it at least. Comets have gotten a lot of press this year, but not all of it is good. In particular, numerous headlines have popped up about a devil comet that's bigger than Mount Everest on its way toward Earth. But what's really going on, you might ask? Let's take a step back and dissect this devil and whether or not you should be worried. Spoiler, you shouldn't. There's a picture here that's associated with this article, so I'll see if I can just bring that up. That's it there. And I'll throw my little insert image just there so you can still see me, that I haven't fallen asleep while I'm reading. Okay, I don't know whether I'll read the whole article. I suppose I could. We'll see how we go. Okay, so what you're seeing there on the screen is comet. I guess it's the big blurry thing in the insert at the right side, the right bottom right side of the picture. It depends on what side of the screen you're looking at. Comet Pons Brooks underwent a second outburst in early October 2023, once again developing horns, as captured here while it was in Draco, constellation. Its real name is Comet Pons Brooks. The so-called Devil Comet has a much less terrifying name, Comet 12P/Pons Brooks. This short period comet orbits the Sun every 71.2 years, similar to the famous Halley's Comet. For the record, any comet with a period less than about 200 years is considered short period. This comet is not a newcomer to the solar system scene. We've known about Pons Brooks ever since 1812, when comet hunter Jean-Louis Pons spotted it at 4th magnitude. But observations of the comet weren't precise enough to predict exactly when or where it would return. So it was rediscovered in 1883 by William Brooks. More modern astronomers working backward think maybe the comet was recorded on previous passes too, as early as 1385. How's that? So, why do we think it's bigger than Everest? Mount Everest, for the record, is just over 29,000 feet, or 8,884 meters high, tall. While determining the size of a comet is difficult without directly observing it via spacecraft or radar, but 2020 paper in research notes of the AAS estimated from its brightness at the time that its nucleus, the chunk of ice and rock that makes up a comet, is about 10.5 miles across, or 17 kilometers. Yep, that's bigger than Everest. Though they warn this is likely an overestimate because the method they use makes it hard to tell exactly where the nucleus stops and the coma or gas, ice and dust coming off the comet surface begins. Still, even overestimating its size doesn't mean it's still a whopping big comet. But Halley, for the record, is just about the same size, some 15 kilometers on its longest side. And we know that one for sure because we've visited with the spacecraft. Why is Pons Brooks being called the Devil Comet at all? Well, in late July, the comet underwent an outburst, blowing off a bunch of gas and dust and brightening by about 100 times, jumping overnight from magnitude 17 to magnitude 12. Such outbursts are random, unpredictable, and not entirely common.
researchers have noted that pond brooks in particular has exhibited such behaviour before and several times per orbit. There's an orbital in here too. That's the general orbit of pond brooks through the solar system. Okay.
That outburst caused the coma to distort into a horseshoe or horned shape, with a dark
centre, bright wings or points. Hence, many media outlets nicknamed it the Devil Comet. Indeed.
Some also called it the Millennium Falcon comet after the ship in Star Wars. After the outburst, the comet settled down again and its brightness remained steady until earlier this month when it outburst again, bringing the horns back. Astronomers aren't entirely sure what's causing the horns, but they think it could be due to the comet spewing gas and dust unevenly. Maybe there's one area of the surface that isn't blowing off steam, so to speak, so it remains dark while the areas either side of it are bright. Or perhaps it's a shadow effect, where denser material or even topography at the centre of the comet appears to block some of the bright material behind it from our point of view. Whatever the reason, it's scientifically interesting because it's intrinsic to the comet and unique structure, but it's certainly not malicious. So finally, and I think there's one more image here. No, that's it? Yeah, that's the only image, okay. So, in addition to making it sound like an evil hornet beast, sensationalized headlines can also give the impression that Pond's Brooks is a real danger to Earth, and sure, it is heading our way-ish, but let me explain why that's really not a concern. When Pond's Brooks surrounds the Sun at the perihelion, it does so from a distance of 0.8 astronomical unit, or 119.7 million kilometers. Astronomical unit is the average Earth Sun distance. So the Earth is 1 AU from the Sun, so that's pretty close and inside the orbit of Earth. And yes, but not even as close as Venus, which lies just over 0.7 AU from the Sun. As Pons Brooks comes into and even flies out of the inner solar system, you might think it has to cross the orbit of Earth to get there. But you know what? It doesn't. Remember that space is three-dimensional. And while all the planets in our solar system orbit the Sun in a relatively flat plane, comets don't have to follow that rule. Pons Brooks has a highly inclined orbit that is essentially bringing it down from above the ecliptic, that plane in which the planets orbit as it surrounds the Sun. So Pons Brooks will pass between the orbits of Earth on the outside and Venus on the inside before heading out to the inner solar system again. It will not ever cross orbit of Earth and can't pose the least bit of danger via impact. The closest it will come to our planet on this orbit is about 1.5 AU on June 2024. That's 1.5 times the distance of Earth from the Sun, so absolutely nothing to worry about. I'll just leave that there, I think. So there it is. The Devil Comet is on its way. Dearie me. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. Next article we have for tonight at 10:30, almost 10:30. JWST captures immense rare explosion 1 million times brighter than our galaxy. A team of scientists used NASA's James Webb Space Telescope to observe an exceptionally bright gamma ray burst. In March of this year, astronomers detected a brilliant burst of gamma rays more than 1,000,000 times more luminous than our entire galaxy. It was the second brightest gamma ray burst, GRB, ever detected and lasted some 200 seconds. A study published today in Nature reports that this object was a collision of neutron stars 1,000,000 light-years distance. What's more, thanks to the James Webb Space Telescope, astronomers were able to see that blast also served as a cosmic chemical factory, forging some of the rarest chemicals found on Earth. The most robust evidence that the merger of two neutron stars caused this burst comes from its kilonova, says lead author Andrew Levin of the Rabound University in the Netherlands, referring to the optical and infrared light coming from the uber-sized explosion. And there's an image here. Let me see if I can just quickly bring that up. Alright. The stunning James Webb Space Telescope photograph published with today's paper shows a kilonova hovering in space some 120,000 light-years from a neighbouring spiral galaxy. The pair of neutron stars that generated the kilonova were apparently ejected from that galaxy as a binary system locked in a death spiral. JWST's exceptionally sensitive infrared instruments made all the difference to the study's success, says Levin. We have seen a handful of these before, he notes, including a kilonova seen in 2017 that was also the first to be detected via its gravitational waves. We didn't have JWST back then, but now we have the ability to probe much redder wavelengths. That is just what you need if you want to understand a kilonovae. Science has come a long way since GRBs were first discovered over half a century ago. At that time, the United States had launched gamma-ray detectors into space to monitor nuclear testing by the Soviet Union. When these satellites detected a sudden flash of gamma radiation far above Earth in 1967, the signal was so unlike a nuclear weapon that scientists at the Los Alamos National Laboratory filed it away for later review. Dozens more were spotted in ensuing years. But the mystery surrounding these events prevailed until the late 1990s, when ground and space-based observatories began linking strong X-ray signals from supernovae in distant galaxies. Today, GRBs are discovered weekly. Astronomers think that most of them are caused by the explosions of massive stars at the end of their lives. Kilonovae represent a subset of GRBs caused by collisions of neutron stars. The incredible dense remains of stars that were massive enough to perish in a supernova, but not massive enough to collapse as black holes. The brightest ever long-duration GRB was detected in October 2022 and nicknamed BOAT, B-O-A-T, brightest of all time. That's the acronym. It blinded most space-based gamma-ray observatories, with a peak lasting several minutes. While BOAT was blinding, this more recent kilonova, dubbed GRB 2303078 for its year, month and day of discovery, provided strikingly clear evidence of individual heavy metals, as well as compelling clues to its neutron star origins. By analysing the radioactive glow in the aftermath of the GRB's relatively strong long explosion, Levin and his colleagues were able to spot heavy elements such as tellurium, as well as rare heavy transitional metals known as lanthanides. Lanthanides. I think that's how you pronounce that. Lanthanides. According to Levan, the creation of one element implies the likely creation of related elements, some of which may have been critical to the earliest life in the universe and the survival of life on Earth. Today's paper not only sheds light, pardon the pun, on how some of the universe's heaviest elements are created, but spotlights the remarkable advances made possible by the world's most powerful infrared telescopes in conjunction with older space observatories like NASA's Fermi Gamma Ray Space Telescope and Neil Gehrels Swift Observatory. Fermi first detected GRB on March 7, 2023. Follow-up observations in visible light wavelengths with Hubble 30 days later saw nothing. But the James Webb Space Telescope's infrared eye was able to clearly detect the glowing aftermath. In addition, because Fermi cannot provide accurate locations, the GRB was pinpointed by triangulation using an interplanetary fleet of spacecraft with gamma ray detectors. They include NASA's Mars Odyssey, launched in 2001 and currently orbiting the Red Planet, as well as the European Space Agency's Bepi Colombo. Bepi, that's what it is, Bepi Colombo, currently on its way to Mercury. GRB 2303078 demonstrates that neutron star mergers can not only generate blasts lasting much longer than a few fleeting seconds, once assumed rare, but also that such phenomena are definitely linked with the production of some of the universe's rarest, heaviest elements. It's been a long mystery how the heaviest elements in the periodic table are formed, says Levin. With these observations, we are able to distinguish where some of the heaviest elements in nature form in the universe. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. How quick we are going through this hour. I'm always amazed at this. Okay, here's another article courtesy of the ABC News. Thank you, Wayne. A cup of coffee. New images of the Ring of Fire solar eclipse may look blurry, but they reveal never-before-seen detail. And I'll throw up this image straight away. There it is, and there she blows, and I'll put myself back there again, or maybe not. I'll take myself out of there for the moment. Okay, so what we're seeing here, in the upper row image, radio images of the solar eclipse, and the bottom row, schematic representation of what visible images of the eclipse looked like. Okay, let's go into the article. On October 14, stargazers and astronomers alike were treated to a celestial event, a Ring of Fire annual solar eclipse. Okay, I've been wondering about that. The phenomenon was visible in parts of the US, Mexico, and South and Central America. Researchers at the New Jersey Institute of Technology Center of Solar Terrestrial Research captured the solar eclipse in a way never seen before. Using the Owens Valley Radio Observatory long wavelength array, they were able to measure radio wavelengths between 20 and 88 megahertz to create an image of the eclipse. In the images and video below, in the article here, the dotted lines show the moon's location and the solid lines show the visible sun's limb. The radio waves extended beyond the sun's edge are emitted from its corona, creating a ring of fire effect. Now I can show you this. Where are we? It's this one here, and I'll cut across to it. and I think I've got it on a loop, so it should continue in a loop. No, it's not going to. Alright, so I've just got to keep that hitting the play button. I don't know why it's not looping, but anyway. But for those watching the video, you can actually see this radio energy. It's a bit tricky because to play that I've got to go away from reading the article, so I'll go back to the article here. Okay, so what you're seeing, the radio waves extending beyond the sun's edge are emitted from its corona, creating a ring of fire effect. And the four images, the two top are at 48 megahertz, and the next is 62 megahertz. Bottom left is 75 megahertz, and of course with the visual. And from our observatory site in California, we were not in the belt to see the annual eclipse, Mr. Chen said. Yet we've been able to see it all clearly unfold in the radio. This reveals a much larger solar disk than its visible counterpart, thanks to its sensitivity to the extended solar corona. Science-wise, this is a unique opportunity to study the sun's extended corona with the highest resolution possible at these wavelengths, taking advantage of the moon's limb as a moving knife edge to increase the effective angular resolution. So, what's an annual solar eclipse? An annual solar eclipse occurs when the moon passes between the Earth and the Sun while it is at its farthest point from Earth. Because the moon is farther away from Earth, it appears smaller than the Sun and does not completely cover the star. This creates a thin, bright ring in the darkened sky, which is nicknamed the Ring of Fire. Okay. So, when is the next solar eclipse in Australia, you might ask? Those eager to see a solar eclipse in Australia will have to wait a few years for the next one. Here are the upcoming eclipses over the next 15 years. July 22, 2028. Totality will cross the Kimberley, Western Australia, through Northern Territory, southwest Queensland, New South Wales, and pass directly over Sydney. Oh, you guys are lucky. Then the next eclipse is November 25, 2030, across South Australia, northwest New South Wales, and southern Queensland. Then on July 13, in the year 2037, southern Western Australia, southern Northern Territory, western Queensland, passing directly over Brisbane and the Gold Coast. And then the next one is December 26 in the year 2038, covering central Western Australia, South Australia, and along New South Wales and Victorian border. Well, it's going to be that long before we get to see anything here in Melbourne. Ah, dear me. Oh, well, okay. Anyway, there it is. So that was an interesting one. I always like the radio side of things when it comes to observations, and we were doing this here in Australia years ago with the heliograph up at Narrabri. If any of you have been up to the Narrabri radio telescope, the array up there, the interferometry, that originally housed 88 radio telescopes in a ring, and it was a heliograph for a radio heliograph for looking and studying at the sun at these wavelengths, doing exactly this sort of thing that you're seeing on the screen as I speak. Going back many years. Those were the days to be interested in radio astronomy and to be in the field of it. Yes. All right, we've got a 5-minute report from from Tamitha. So I'm going to try and leave some space for her. This next article, which I think isn't very long, The search for intelligent aliens explores new radio frequency realms, published only 13 hours ago. And there's a picture associated with that. I'll bring that up. Okay, and I'll put me in there. The European Low Frequency Array of Radio Telescopes is performing breakthrough Listen's first ever search at megahertz radio frequencies. And the picture on the screen is a view of the LOFAR station at Bryre Castle in Ireland, which has been listening for alien radio signals. A new European search for extraterrestrial radio signals at low uncharted frequencies is now underway, having already listened to over 1.6 million star systems. SETI, the search for extraterrestrial intelligence, has traditionally focused on radio frequencies higher than a gigahertz, such as the hydrogen line frequency at 1.42 gigahertz. SETI astronomers tend to shy away from the lower frequencies because of Earth's atmosphere renders observations noisy. However, Europe's Low Frequency Array, LOFAR for short, is specially designed to conduct radio astronomy at these frequencies. LOFAR is an array of radio antennas that span hundreds of kilometers across Europe, centered in the Netherlands, but with additional stations in France, Germany, Ireland, Latvia, and Poland, Sweden, and United Kingdom. These stations incorporate two types of antenna: low-band antennas that operate between 10 and 90 MHz, and high-band antennas that listen to the universe between 100 and 250 MHz. In conjunction with the Breakthrough Listen SETI project, the LOFAR stations in Ireland and Sweden have been using in conjunction with one another in the first part of Breakthrough Listen's first ever low-frequency search. This search used the high-band antennas to listen for radio signals at frequencies between 110 MHz and 190 MHz. Primarily, the search is looking for leakage from high-power transmitters such as planetary radar or communication with spacecraft. The search encompassed 1,631 actually it's a bit more than that, 1,631,198 target star systems identified by NASA's Transiting Exoplanet Survey Satellite, or TESS, and the European Space Agency's GEA astrometric probe. By using multiple sites in Ireland and Sweden, astronomers were able to negate the effects of radio frequency interference and quickly rule out any false positives. For example, if an anomalous signal were only spotted by one station and not the others, it would be local interference. Only a signal coming from space could be detected by all the stations. Yes, I know something about that. No narrowband radio signals with a distinctive frequency drift caused by orbital motion of an exoplanet hosting a transmitter beaming out signals from a power of at least tens of millions of watts were detected. However, the low-frequency search is only just beginning, and improvements in coming years will increase its sensitivity. LOFAR is soon to undergo a staged series of upgrades across all stations in the array across Europe, which will allow even broader SETI at ranges of 15 to 240 MHz, said graduate student Owen Johnson of the Trinity College Dublin, who is the lead author of the new paper describing the results. Among these upgrades will be two new LOFAR stations in Bulgaria and Italy. Computing software and artificial intelligence algorithms will also speed up the analysis of the results. We have billions of star systems to explore, and we will be relying on some machine learning techniques to sift through the immense volume of data, said Johnson. That in itself is interesting. It would be fairly ironic if humankind discovered alien life by using artificial intelligence. The first results from LOFAR SETI search was published on October 24 in the Astronomical Journal. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Just seeing what else I had here. There's 3 more articles which I could squeeze in if I didn't worry about Tamitha's solar report. I might leave that till next week, and I'll leave that possibly till next week. And that's a short article. Let me squeeze this one in before I go to Tamitha. Testing 1 2 3, and I'll throw up this picture. Can anybody guess what that is? Oh dear. Alright, quickly. Quakes on Mars reveal. I'll start that again. Quakes on Mars reveal we were wrong about its core. 26th of October. And what you're seeing on the screen is an artist's reconstruction of the internal structure of Mars, just in case you weren't aware of that. Mars may have a hard, dusty shell, but its interior is layered like a jaw breaker and surprisingly squishy. 2 new papers published in the journal Nature detail the way seismic data reveals the specifics of the Martian interior. Each shows a 150 kilometre, 93 mile thick layer of molten silicate rock at the base of the mantle envelopes Mars' liquid iron alloy core. This could have implications for our understanding of Martians' history, but also may have an effect on the way we interpret Mars' seismic data collected by Mars InSight lander between 2019 and 2022. Aside from Earth, Mars is the only planet with an interior structure we've been able to probe with seismic data. InSight, which was only operational for a few years, detected hundreds of quakes rumbling through the guts of Mars. This revealed that Mars has a lot more going on inside than we previously thought, but an analysis of those rumbles also revealed the planet's interior structure, and here is a graphic. Here is a graphic. There she goes. And I'll get rid of my insert there. So there it is. So what you're seeing there is a diagram showing how seismic waves moved through the Martian interior and the newly discovered layer. When quakes shudder through a planet, waves propagate through and reflect off different materials in different ways. A solid, rigid material is going to have a different seismic profile than an elastic, squishy one. Scientists were not only able to use seismic data to probe what's inside Mars, but map it in detail. The initial map was based on early data. The 2 new papers, led separately by geophysicist Amir Khan of the ETH Zurich and geophysicist Henry Samuel of the French National Centre of Scientific Research, respectively, are based on a much larger data set, including 2 huge seismic events thought to be the result of a meteorite impacts. Earlier measurements suggested Mars had a surprisingly large core, with a radius of about 1,830 kilometres, and that's huge, over half the planetary radius of 3,390 kilometres. It also meant that the core would have a relatively low density, suggesting a fair amount of lighter elements were mixed in. And here is another graphic of this thing. There it is. Okay. So here the diagram demonstrating the researcher's measurement. So this in turn means that the core must be smaller, between 1,650 and 1,675 kilometres in radius. That's in line with previous estimates of the size of Mars' core prior to InSight's observations of the planet's interior. If the core is smaller, that means it's denser too, which means it doesn't need those extra lighter elements to fluff it up. That's much more consistent with our understanding of Mars's chemical composition. Given that the core composition of Mars contains clues about its history, the hypothesized presence of lighter elements was previously implicated in the loss of Mars's global magnetic field, and this could help scientists figure out how Mars got to be the way it is today: dusty, arid, lifeless, and fascinating. Although the two papers agree on the molten nature of the layer as well as its size, they have different theories on how it got there. Future research could help narrow down the mysterious history of the evolution of Mars. These papers appeared in Nature. So, I thought that was a entertaining thing to read out. Where's my camera? There it is. Alright, let's quickly go across to Tamitha's latest report. I did have her queued up. There she is. It's only a 5-minute one, so she's covering all this weekend. So let's see if we can get her online. Stand by for Tamitha.
We have 2 wispy solar storms on their way to Earth, some fast solar wind, and some big flare activity maybe just around the corner. Those stories and more in the Spotlight. Space weather this week kicks off into high gear. As we take a look at region 3467, it launches a wispy solar storm. You can see right here in our solar demon, all that dimming region. That is actually an Earth-directed solar storm, but it is wispy, so we're not expecting all that much. But we do have a coronal hole that you can't really see right here, but that is also giving us a little bit of fast solar wind. On top of that, if you take a look at the far shot of the sun, you can see wispy prominence eruptions. These are big solar storms that are not Earth-directed, but man, do they sure make some nice eye candy. And on top of that, as we zoom into the sun, we actually have another filament right here. This filament is about to erupt right here. You'll see it whoosh, kind of right there. Yep, that is an Earth-directed solar storm as well. It's also a wispy solar storm, so that one is going to hit us later this week. And on top of that, it's going to be chased by some fast solar wind from this coronal hole. So aurora photographers, if you're at high latitudes, you're definitely going to be getting a show over the next couple days. And aurora photographers at mid latitudes, well, you might get a chance for a show as we move later in through the week. Now, taking a look at our solar storm conditions and aurora possibilities over the coming week, we are expecting to get that solar storm hit. But really, actually, we're getting it right now, and it's kind of giving us unsettled conditions because it's basically a wispy solar storm. But aurora photographers, if you're at high latitudes, you definitely could be getting a bit of a show. Plus, it's going to be chased by some fast solar wind, as you can see here. But we're only expecting up to about a 25% chance of a minor storm at high latitude, so it's not going to be all that big a deal. But as we move to the latter part of this week, you're going to see minor storm conditions when that second solar storm hits Earth. And that's good news because you're going to get a better chance for some aurora shots. Plus, we're going to get a bit of a fast wind chaser, but that may not happen until the beginning of next week or the beginning of November, essentially. So you're definitely going to get a shot for some aurora, possibly through Halloween. It looks like you might just get a chance. Now, switching to our solar storm conditions at mid-latitudes, well, we are expecting a little bit of activity, and we're kind of getting it right now. It's only going to be unsettled conditions with about a 10 to a 15% chance of active conditions over the next couple days because of the fast solar wind along with that wispy solar storm. And then when we hit the 29th, we should get a bit more activity from that second wispy solar storm that's going to hit Earth, and that's going to be followed by a fast wind chaser. And so aurora photographers, if you're at mid-latitudes, we could expect active conditions with up to about a 20% chance of minor storm conditions. And then as we move into Halloween and through the first of the month, we could get a little bit more activity. So, if you're dedicated, you could chase, but, we're going to have to wait and see. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we really don't have a lot of activity right now. We've got just a couple active regions in Earth view, which doesn't mean all that much. Believe it or not, we're sitting at the low noise floor right now with only about a 1% chance of any radio blackouts at all. Now, we do have some new regions that are going to be rotating into Earth view here over the next maybe 2 to 5 days, and that could actually get us to bump up to minor noise conditions, still only expecting about a 5 to 10% chance of radio blackouts at the R1 to R2 level, and everything else should be pretty calm. So amateur radio operators, well, on the day side, you should be getting some decent radio propagation right now, and that's likely going to continue throughout the rest of this week with only a little bit of increased noise as we get in close to the beginning of the new month. And now switching to our radiation storm and polar aviation outlook over the coming week, everything is in the green when it comes to radiation storms. We're sitting at the D1 normal range. That's at flight level 360, which is also the S0 quiet range for all the rest of us. We really don't have any risk at all for big radiation storms. This is going to continue easily throughout this week and possibly into next week before things change at all. So you frequent flyers, and this does include air crew and you high-risk passengers, it looks like you're all in the clear. So the space weather this week is picking up. We do have a couple of wispy solar storms either hitting Earth or on their way to Earth now. Aurora photographers, if you're at high latitudes, you could get a bit of a show. Aurora photographers at mid latitudes, well, you're going to have to wait closer to Halloween in order to get a bit of a show. But it could give you some decent aurora then with some fast solar wind. As well as that, amateur radio operators, you're getting a break this week because we definitely don't have any big flare players in Earth view, and that's good news because that means your radio propagation is looking wonderful. And now you GPS users, well, you know, we don't have any big solar storms on the Earth's night side to bother you, and we don't have any big solar flare players that are giving you big radio blackouts. So believe it or not, the space weather conditions and your GPS reception pretty much all over the globe should be top-notch. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay. Thank you, Tamitha. This is VK3EKH. Now, I've just been reading some notes coming through that there's been some issue with the audio. I don't know why. I haven't actually been monitoring myself with the headphones on, but I am now. But what's going out over 80 meters sounds pretty good. There's plenty of level there. I've been keeping an eye on the level on YouTube on vMix, and I can tell at the moment that the YouTube channel would be a little bit too loud. Because I did knock it back to 1, 2, 3, 4, 1, 2, 3, 4. Yeah, I can hear in the headphones how that's knocked the level down on 80 meters, and I was off the microphone before when I was reading those. Look, from what I can hear on the headphones, it sounds all right. And there's, I don't know why the audio was dropping out. Everything was telling me that it was all okay, so. I don't know. It's working fine now. Anyways, Richard seems to think that it was also being affected on YouTube as well. So I don't know what's going on there. Anyway, all right. So that's the solar report from Tamitha. And if we just quickly go to spaceweather.com, like I always do, finish off with the follow-up. Our disk of the sun looks like this at the moment, and the solar wind is currently at 385.1 kilometers a second at a density of 3.61 protons per cubic centimeter. There are, have I got the right sun up here? Let me just have a quick look at that. It was vMix. Yes, I think it's the right one. Yep. Okay. There's 4 sunspots visible on the disk of the sun facing us at the moment. Sunspot number is 57, and the radio sun is currently 126 solar flux units, measured at a wavelength of 10.7 centimeters. The aurora over the Antarctic is looking a bit like this at the moment. It's quite a decent glow. If you're in the south part of Tasmania, you might see a little bit of evidence there on the southern sky. What else? The KP index, planetary K index, the current KP index is 2.67, which is considered quiet. The 24-hour max for the KP is 4.67, which is considered unsettled. And Timothy mentioned about the coronal hole in the sun facing us at the moment. That's currently what it looks like for those watching the visions. And as far as geomagnetic storm watch goes, there is a minor G1 class geomagnetic storm is likely on October 30, as Timothy was saying, when the solar wind stream is expected to hit Earth's magnetic field. The gaseous material is flowing from a double-lobed hole in the sun's atmosphere. And there was a dramatic solar flare, which I do have a GIF image here of. Let me just bring that up quickly. And there it is. That's on a loop. So so dramatic M-class explosion. A magnetic filament just beyond the sun's northeastern limb exploded on October 26 at 23:24, causing a chain reaction of magnetic eruptions that spilled into the Earth side of the sun, and you can see that happening there. Coronagraphs on board the Solar and Heliospheric Observatory, SOHO, have since detected a fast-moving CME emerging from the blast site. Type 2 radio emissions from the leading edge of the CME suggest it is moving at 1,558 kilometers a second, and there is a hint of an Earth-directed component, and it is too soon to know for sure. So yes, there's a little bit of an update on the solar flux here. NOAA forecasts quicker, stronger solar max, and there is a graphic for that too, which I'll quickly bring up for those watching the visions. What they're saying here is when solar cycle 25 began in 2020, leading forecasters thought it would be weak and slow develop. Fast forward 3 years, NOAA is now predicting a quicker, stronger solar cycle. The revisited forecast published yesterday shows solar max coming sometime between January and October next year. And that graphic on the screen there is kind of illustrating this. NOAA's original prediction for solar cycle 25 is shown in pink. The broad band indicating of uncertainty of the forecast. It has become clear in recent years that the original prediction was too low, which prompted NOAA to issue a new one. And the magenta line traces the new forecast and takes it into account recent high spot counts. So there it is. Solar cycle 25 is likely to peak earlier, and we're looking at between January and October next year. So next year is going to be a ripper for HF activity, I would say. To finish up on, let me just bring my camera back on, as I normally do. Potentially hazardous asteroids are space rocks larger than approximately 100 meters, and that can come closer to Earth than 0.05 AU, but none of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. As of October 27, there were 2,349 potentially hazardous asteroids. I always find that amazing. Anyway, that's it. Thank you for listening, everybody, and I apologise if the audio was dropping out. I had no evidence of that here in front of me. I was off the microphone a little bit because I'm just conscious of not overdriving YouTube level, but everything else was telling me that things were okay, and I wasn't touching and moving anything here in the shack, so audio should have been there all the time. I shall review my YouTube when I stop recording I shall review my YouTube and see exactly what was happening. But I can see most of you have all been making comments, so I don't know what it was. Yeah, there it is. Okay, so let's now open up the frequency to any stations wishing to call in. And let's see who there is. It's 10 past the hour. And let's see who else is out there. This is VK3EKH listening on 3541. Okay, I think it was, Frank, VK3JR, were you there?